Hey folks, it's the Acceleration Lab, so I'm here to help you out with the Excel analysis that you have to do. So with this lab, I'm going to have you do a lot of the calculations that I would have done for you, but I'm going to show you how you can get Excel to do these calculations to your benefit so you don't have to do them all by hand and plug everything in by hand. So right now in the screen column, I've got already my position data that I recorded in the lab entered in here. You don't have to have this in quite yet to get all the equations set up and ready to go, but it does help. So at some point you do have to have your position values plugged in. Now again, feel free to pause, rewind, whatever when we do this, when you're going through this video, so you can work at your own pace. So we have columns for dot, time, position, velocity, and acceleration. So dot, we're starting with our quote unquote zero dot, and then it's just going to go 1, 2, 3, 4, 5, and so on and so forth. So you could type those in by hand, or you could say that this cell here below the zero is equal to, so you have to type along to what I do. So again, this is where the pause, rewind, whatever helps. So this cell below the zero is equal to, so you got to hit equals, and then you're going to click on this 0, so cell A2, you're going to click on there, and then you're going to hit +1, and then enter. So what this does is it references cell A2, and then adds 1 to that value, and that's the value it's going to put into cell A3. So now we see this little lower right-hand corner of cell A3 here. So where the cursor changes in the lower right-hand corner is this little plus sign. You can actually click and drag and bring that down. So now it auto-filled in 2, 3, and 4. So I'm gonna click and drag all the way down to fill in for just my position values. Okay, so up until there. So it looks like I have 28 data points here. Well, 29 including the 0. Now, each of these dots are 1/10 of a second apart. So after my dot 0 is at quote unquote time 0, my next one is 0.1 second later. So what I'm actually going to do is I'm going to say that this cell B3, I'm going to type equals to, and then I'm going to click the cell to the left, so this 1, and then divided by 10, hit enter. Okay, so then again, lower right hand corner of this cell with 0.1 in it, when the cursor changes to a plus sign, you can click and drag that down. So it's filling in. So you see it's 1.1, 3.3, 5.5. And then you can either click and drag all the way down, or at this point you can actually double click and it'll auto fill in just for the data points that you have, and it shouldn't go any farther. Now back up here. So we are starting at rest, so we have an initial velocity of 0. So starting in cell D3, we're going to try and do some velocity calculations. So remember, velocity by definition is a change in position values over a change in time values. So in cell D3, I'm going to hit equals, and no spaces anywhere. I'm going to hit equals and then open parentheses. So I'm going to select my data point in cell C3 and then minus C2. So that right there, close parentheses, that right there is going to be a change in position, and then divided by, open parentheses again, this is important, you got to have the parentheses there, your 0.1 minus your 0. So cells B3 minus B2, close parentheses, hit enter. So if I click back in the cell which I just typed into, up here you can click and it'll show you what cells it's using to calculate with. So again, lower right hand corner of this cell, you can double click and it'll auto calculate all those velocity values for you. So if you notice here, let's take a look at what we got. So starting off at rest, my velocities are increasing up until about here. So 1.4, 1.5 seconds, my velocity is getting bigger, which it might be a different time for you. And then after that, my velocities are starting to get back to go smaller again. So we're approaching 0. So we have a period where we are speeding up for about the first 1.4, 1.5 seconds or so. And then after that, we have a period where we are slowing down for the rest of my data. And now acceleration. So up in cell E2, no 0 at the top. This is the only column without a 0 at the top. But dot, time, position, velocity all should have a 0 at the top. So if they don't, you're going to want to go back and fix that. So acceleration, you're going to type equal to and then open parentheses. So acceleration is a change in velocity values. So cell D3 minus D2, close parentheses, and then divided by, open parentheses, B3 minus B2. Close parentheses, hit enter. So there's my acceleration for the first time interval. So then again, click in there, lower right hand corner where the cursor changes. You can click and drag down or double click, and it should do all that for you. So again, a lot of what we've been talking about is the relationship between, velocity, acceleration, and whether or not that means we're speeding up or slowing down. So we said for about the first 1.5, 1.4, 1.5 seconds, we have a increasing velocity. So we know that corresponds to basically a positive acceleration for basically that entire time interval. And then after that, I have what is basically a negative acceleration because we are slowing down at that point. So I'm going to want to make some position velocity and acceleration graphs and copy those into OneNote. So first up is position and time. So I'm going to just click and drag, select my time and position data. Okay. So we got that. Insert. Dots. Looking really good here. So this is a position versus time graph. Okay, I'm going to want some axis titles. So in here we're doing position. We're measuring in centimeters on the y-axis, and then here this is time on the x-axis. So you can see we got this beautiful, curving up. So getting steeper up until about here, which is around 1.4, 1.5 seconds. And then we, start to flatten out after that. If this graph continued, it would kind of curve up, and then it would start to curve down and flatten out. If this graph continued, it would just be flat, just continuing on forever, because the objects stop at that point. So no trend lines or anything on this one, but you can copy and paste that over into OneNote if you need to. Next up is the velocity versus time graph. So I'm going to select my time data. Now I know velocity and time are not next to each other, so it's a little bit more difficult to get this graph going, but select your time data. Now at this point, if you're on a PC, you're going to want to hold down Control while selecting your velocity data, or if you're on a Mac, you're going to hold down Command while selecting your velocity data. So I'm on a PC, so I'm going to hold down Control, click and select your velocity values. Let go of your mouse, let go of Control or Command, and now you can make your graph. So insert. Okay, this is a velocity versus time graph. And I want some axis titles. So this is velocity in centimeters per second, and this is time in seconds. So I'm just going to kind of try and overlay these on top of each other as best I can. Again, so let's look at what these graphs are telling us. So you have to copy and paste this velocity graph over into OneNote at some point, so make sure you do that. But again, so looking at the velocity graph, we're starting at 0, and then we're increasing our velocity up until about 1.4, 1.5 seconds. You might have a slightly wider, flat section here, which is okay. And then after, for me, about 1.5 seconds, it looks like it's going all the way back down. So we have a period of increasing speed, decreasing speed. So our period of increasing speed corresponds to the position graph when we're getting from flat to steep, 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 up until about 1.5 seconds. And then we have our decreasing speed period and on our velocity graph, and then our position graph. So decreasing speed means we are curving up but essentially flattening out. So those two sections correspond to each other. And then last is our acceleration versus time graph. So again, select your time values. Hold down Control on a PC or Command if you're on a Mac. Highlight your acceleration values. This one's going to look really funky, and it's really not going to look pretty at all. But honestly, that's okay. I wouldn't worry about it too much. Let's just throw it in. This is an acceleration versus time graph. Oh, oops, my bad. Excuse me. I have to do that again. All over the place. Sorry, folks. Insert. There we go. This is an acceleration versus time graph. And then we need some axis titles. So acceleration is in centimeters per second squared. So for the square, just do the caret, which is the character on the 6 button, 6 key, and then squared, close your parentheses. That'll be good enough for us. Come on. Time in seconds. Okay. So copy and paste those 3 graphs over into OneNote. Now, we also have this little mini table right over here. So part of the pre-lab was trying to get you to realize that the acceleration is the same value as the slope of a position graph. So you could make 2 more graphs to get our acceleration values when we sped up and slowed down. But that might not be the most fun. There's a quicker way to do it by having Excel do the calculation for you. So again, slope of a velocity graph is acceleration. So for my increasing speed, I'm going to hit equals to, and then I'm going to type the word slope, and then I'm going to open my parentheses without hitting enter or anything. So first up, we have to select our y values, which are our velocity values. So I want to select the velocity values where I am speeding up. So I'm basically going to go up until this kind of 1.4, 1.5 second mark. For me, whatever your data, wherever that's increasing, that's what you have to do. And then comma, now I'm going to select my known x values, which are the corresponding time values for the velocity values that I just highlighted. So you see they're both the same sets of numbers here, same span. Close your parentheses, hit enter. So that's the slope of just that mini data set there. So while I sped up with an acceleration of 46.8 about centimeters per second squared. Now slowing down, same thing. My acceleration or deceleration is the slope of my velocity data. So I'm going to hit equals and then slope, open parentheses. Now my y values again while slowing down. So I got to go down here and select my velocity values because it's velocity on the y-axis, comma, and then we can do the x values, close parentheses, hit enter. And up here, so while I slowed down, I had a deceleration of negative 48.1 centimeters per second squared. So these 2 values should come in handy later when we do the Excel analysis. So again, copy and paste your position, velocity, and acceleration graphs into OneNote and keep note of these 2 values here. You're going to have to probably pull them up later.